So this will discuss problem number 4 from the 2024 AP Stats exam. And this was the problem from 2024 that dealt with probability. So the setup for this one is we've got an online game. Players are going to move through a world collecting geodes, which is a hollow rock. When they open these geodes, they're going to contain crystals of different colors that are useful in the game. A red crystal is most useful in the game. The color of the crystal in each geode is independent, and the probability that a geode contains a red crystal is 0.08. So Sarah's a player in the game, and she's going to collect and open geodes until a red crystal is found. Now, because we are looking at independent events when we open the geodes, and the probability of getting a red crystal is fixed at 0.08, and we're trying to measure the number of trials until Sarah gets a red crystal, this is going to follow a geometric distribution with a probability of a red crystal being 0.08, and we're asked in part A to figure out the mean of the distribution of the number of geodes she's going to need to open until a red crystal is found. So this is right off of the formula sheet. So I have a formula sheet here, right? So on the front page of it, you've got some geometric distribution formulas across the bottom of this row here. We're actually going to need this formula for the first calculation in part A and this formula for the second. So as long as you recognize that this was a geometric distribution with a probability of success being 0.08, the mean of the distribution is going to come from an application of this. So 1 divided by 0.08, so 12.5 geodes on average would have to be opened until Sarah finds a red crystal. And then the standard deviation, the actual number of geodes she's going to need to open until she gets a red, is going to deviate from that mean by about 12 geodes, 11.99 geodes on average. It does ask you to show your work in each calculation, so showing this intermediate step is definitely something necessary to do. Part B says we've got another player, Conrad, and he's going to play the game and will stop opening geodes after finding a red crystal or after he's opened 4 geodes. So Y is going to be the number of geodes Conrad's going to open, and the table that we have access to shows the partially completed probability distribution for random variable Y. So obviously these values I have filled in based on some of the calculations that we are about to discuss. Now the first calculation is to figure out the probability that the number of geodes Conrad's going to need to open is exactly 3. We are asked to show our work. Now in that same portion of the formula sheet, we have the formula for computing a geometric probability when x is equal to a fixed value. In this case, y is taking on the role of x, and y is fixed at 3. So what is that probability going to be? Well, I'm going to take 1 minus the probability of success, so the complement of the probability of success. I'm going to raise that to a power that's 1 fewer than what I'm trying to measure to. And the reason for that, I'll try to explain it within context here. This power would be 2. If I have 3 minus 1 in that exponent, I would have 2 failures, right? 92% chance of failure. 0.92 is the probability of not getting a red geode. So I'd have 2 of those times the probability of getting a red on the third. So doing that calculation ends up giving me the value that goes in this position, which is 0.0677. And then we're asked to also find the probability that y is equal to 4. Now, this is not going to be done with a geometric calculation. The reason why is indicated by the process that's detailed up here. If he does not get a red geode when he opens that if he does not get a red crystal by the time he opens that 4th geode, he's done, he's turning off the game, he's not coming back till the next day. So the sum of all of these probabilities across this bottom row has to be 1, right? A probability distribution table, the total of all of the probabilities within it, of all possible events, has to be 1. So if I use a complement and subtract off the probabilities I know, the one that they gave us, the second one they gave us, the one we just computed, we end up with the probability that either he gets that red crystal on the 4th opening or no red crystal, shuts the game off, done till the next day. We're now asked to consider what we did back in part B. and asked to calculate the mean of that distribution for the number of geodes Conrad's going to open, and we are asked to show our work. So this would be the expected value, the expected number of geodes Conrad's going to need to open when he goes through this process to get that red crystal or to stop opening after the fourth geode has been cracked. So the way that we would find the expected value, and I'm going to click over to the formula sheet one more time, we do have for a discrete random variable, and again, we're using random variable y based on how this information was presented, but the way that we're going to find that expected value is we're going to take what the outcome is, so the number of geodes that would need to be opened in our case right now, times the probability of that number needing to be opened. So basically I'm just taking that table that we computed and filled out back in part B, and I'm multiplying the values that are one above the other, adding what I get when I do this multiplication, adding what I get when I do this multiplication, and adding what I get when I do this multiplication. It does ask us to show the work, so we would have to show that top line, and then if you fire that into a calculator, what you end up figuring out is the expected number of geodes that Conrad's going to open when he goes through this process is 3.545. Now we are asked to interpret the mean of this distribution that Conrad's going to have to open. And so when you're asked to interpret an expected value, you have to show that you recognize that this is what would happen if this process is repeated over and over and over again. So if Conrad daily repeats the process of opening geodes until receiving a red crystal or until 4 geodes have been opened many, many, many times, if he does that daily for years, on average, Conrad's going to be opening 3.545 geodes per geode opening session.